Good morning, students. Good morning.
Good morning, ma'am.
Okay, very good morning. What happened? All of you are remaining silent. The lack of energy, what happened today? All right. Any problem? Okay. So yesterday we were discussing about Ohm's law. So we can start with the equation of Ohm's law and that we can discuss the same topic today. And what about your seminar? So yesterday we were discussing about Ohm's law. Rose, can you recall the equation for Ohm's law? V is equal to IR and try to differentiate each term present in this equation.
V is equal to voltage, I is current, and R is proportional to constant.
R is the resistance. All right, very good. Then next one, Heinz-Steve. What is the relation that established by ohms with the help of this voltage and the current?
Einstein's relativity.
Is it Einstein's relativity? Ohms established Einstein's relativity was a contradictory statement. Heinz-Steve,
Yes, ma'am.
what is the relation that is established by ohms regarding with that of the current and that of the potential difference or voltage? How they are related?
Ma'am, I don't know.
Okay, then the same question to Rizwan.
Yes, ma'am.
What is the relation between current and potential difference that is established by our George Simon Ohm, the German physicist? Melvin, what are you doing there? The same question to you.
Yes, ma'am.
What is the relation between current and potential difference that is established by our George Simon Ohm?
Ohm's law is V is equal to IR.
And how this potential difference and current is related to each other? What's the relation between these two terms, current and potential difference?
Potential difference is equal to
Who can say the relation between current and potential difference?
Directly proportional.
Very good. The potential difference and current is directly proportional to each other. That is, whenever the potential difference increases, what happens to current? Current is also increases. So that is what is we are discussed yesterday. So first of all, you copy down the statement of Ohm's law. After that, we can discuss the graph of Ohm's law. So today we can discuss the statement of this is who is the George Simon Ohm, the German physicist who established the relation between the potential difference and the current. Now we can state the Ohm's law. This is the statement of Ohm's law. This is very, very important. At a constant temperature. So in order to satisfy this Ohm's law, a condition is needed. This condition is necessary for the satisfaction of this Ohm's law. That is, all these process, that is the potential difference is directly proportional to the current if and only if the temperature is remains a constant. So what is Ohm's law state? At a constant temperature, the potential difference V across the ends of a conductor in an electric circuit is directly proportional to the current flowing through the circuit. This is the statement of Ohm's law. So you can expect a sure question from this portion, Ohm's law. State the Ohm's law and write the mathematical expression for it. What is Ohm's law? At a constant temperature, the potential difference V across the ends of a conductor in an electric circuit is directly proportional to the current flowing through it. All of you please copy down this Ohm's law. So the Ohm's law states that the potential difference V, where this potential difference V is located, this potential difference V across the ends of a conductor. And here this conductor is connected in an electric circuit. So the potential difference V across the ends of a conductor in an electric circuit is directly proportional to the current flowing through the circuit. And what is the necessary condition for the satisfaction of this Ohm's law? It is constant temperature. All these processes takes place under a constant temperature. So at a constant temperature, the potential difference V across the ends of a conductor is directly proportional to the current flowing through this circuit. Is it over? Okay. At a constant temperature, the potential difference V across the ends of a conductor in an electric circuit is directly proportional to the current flowing through the circuit or flowing through it.
Ma'am, what is the temperature?
Temperature is depending upon that we take. Sometimes if we are taken it as, most probably in our physics lab we are consider it as our room temperature. The room temperature 273 degrees Celsius. Okay. Temperature must be a constant, and we are doing this experiment in physics lab by keeping the room temperature as a constant level.
Hot or cold?
Hot. We are kept in a room temperature, not extremely hot or room temperature. The condition is that temperature must be a constant. The temperature must be constant. At a constant temperature, the potential difference V across the ends of a conductor in an electric circuit is directly proportional to the current flowing through it. That is, here we know that the voltage is measured with the help of a potentiometer. Voltage is measured with the help of a voltmeter, and this voltmeter is connected across the ends of a conductor, right? Here it is connected across the ends of a conductor. And what is this X and Y represents? Can you recall what is this XY represents? Yesterday we discussed the same experiment in the class. What is this XY represents? It is a material made up of an alloy. What is its name? Yes. Nichrome wire. It is our nichrome wire. And this nichrome wire is made up of it is an alloy. It is made from the metals like nickel, chromium, iron and manganese. And here this voltmeter is used to measure the potential difference. This voltmeter is connected across this nichrome. Here the nichrome is acting as a conductor. So what is the Ohm's law state? The potential difference across the ends of a conductor in an electric circuit is directly proportional to the current flowing through the circuit. The potential difference connected across the ends of a conductor. Okay, here the potential difference V, the voltmeter is connected parallel to this nichrome wire, or it is connected across the ends of a nichrome wire. This nichrome wire is acting as a conductor here. So the potential difference across the ends of a conductor in an electric circuit is directly proportional to the current flowing through the circuit. Is it clear? And what is the necessary condition for it in order to satisfy the Ohm's law? What is the condition?
It want to be in a room temperature.
Oh, not only in room temperature, it must be takes place in a constant temperature. It must be in a constant temperature. So the Ohm's law states that the potential difference V across the ends of a conductor in an electric circuit is directly proportional to the current that flowing through this circuit at a constant temperature. This is the statement of Ohm's law. Is it clear? Is it clear or not?
Yes, ma'am.
Okay. Then according to the statement we have an equation. V is directly proportional to I. V is directly proportional to I. In order to replace this proportionality sign, we introduce a constant. What's that constant? Yesterday we have already discussed about that constant. What is that constant known as?
Resistance.
It is resistance. Very good. We introduce a constant R, and this R is known as resistance. This R is known as resistance. So according to Ohm's law, the potential difference V developed across the ends of a conductor in an electric circuit is directly proportional to the current I flowing through the circuit. So we can write V is proportional to I. And in physics we have a tendency to replace this proportionality sign with the help of a constant. And here that proportionality constant is R. What is R? R is the resistance of the circuit. Okay. So V is equal to IR. V is equal to IR. In this equation, V is the voltage or the potential difference. What is I represents I? Here. What is I represents? Current. And what is R represents? R? R is the resistance of the circuit. What do you mean by resistance? Any idea? Very good, very good. Resistance, it is the property that opposes the or resists the flow of current in a circuit. That is what is known as resistance. And this proportionality constant resistance is introduced by Ohm. So the unit of resistance is Ohm. What is the SI unit of resistance? The SI unit of resistance is Ohm. Okay. So here we have V is equal to IR, where V is the voltage or potential difference, I is the current, R is the proportionality constant. That proportionality constant is known as resistance. Resistance is the property to oppose or resist the flow of a current in a circuit. So students, can you form an equation for resistance from this equation? What is resistance?
R is equal to V by I. V by I.
R equal to V by I. Very good. R is equal to V by I. So here from the Ohm's law we can calculate the value of resistance in a circuit. R is equal to V by I, where V is the voltage and I is the current. R is the resistance. And this proportionality constant resistance is introduced by whom? Ohm. It is introduced by George Simon. Okay, I will show it. I will show it. You just listen here. Here the resistance, the proportionality constant resistance is introduced by George Simon Ohm. So in order to honor him, the SI unit of resistance is Ohm. SI unit of resistance is Ohm. And it is represented by a Greek symbol. This is the Greek symbol to represent Ohm. Just like the ear of Mickey Mouse, right? Some students may say like that, this is the ear of Mickey Mouse and all. I don't know. Okay, now I will show the previous slide. Which one? Ohm's law?
No, ma'am, that equation.
Okay. So this is the mathematical representation for the Ohm's law. V is directly proportional to I, that is the potential difference across the ends of a conductor in an electric circuit is directly proportional to the current flowing through the circuit by temperature remains a constant. In order to replace this proportionality sign, we introduce a constant. That constant is known as R, resistance. Since this constant resistance is introduced by Ohm, George Simon Ohm, in order to honor him, the SI unit of resistance is named as Ohm. It is represented by a symbol this. From this Ohm's law we can calculate the resistance value. R is equal to V by I, where V is the voltage or the potential difference across the circuit, and it is expressed in terms of volt. Volt is the SI unit of potential difference. And here I represents the current. I represents the current. And what is the SI unit of current? Emil, can you recall the SI unit of current?
Ampere.
Very good. It is ampere. Excellent. It is ampere. And what about resistance? Resistance is the opposition, or it is resist the flow of current through a circuit, and it is expressed in ohm, and the Greek symbol of ohm is this. So instead of writing ohms, you can express in terms of its symbol. For example, if a circuit with a resistance of 2 ohms, instead of writing like this ohms, you can represent it like this, 2 ohm. This is also right. Is it clear?
Yes, ma'am.
Okay. Now can I change the slide? And this is it's a clue to study this Ohm's law. Actually, this Ohm's law is also known as triangle law. The Ohm's law is also known as triangle law. If you study this triangle form, you can easily form the equations from this Ohm's law. Here we know that V is equal to I into R, right? V is equal to IR. And what is R? V divided by I. Resistance. R is the resistance, and from this equation how we can calculate R? V divided by I, right? V divided by I. So here R is here and V is in the numerator and I in the denominator. Similarly, from this equation we can also calculate I. How we can calculate I? I is equal to? Very good. V divided by R. Here V is in the numerator and R is in the denominator. Is it clear? So Ohm's law is also known as triangle law. So if you have a diagram like this in your mind, you can easily formulate the equation I is equal to V by R is equal to, here R is equal to V by I, or V is equal to IR. V is in the numerator. So we can give the V is equal to the product of current I into the resistance R. Here we want to calculate this V. How we can calculate V? Product of I into R. Similarly, we want to calculate the current I. I is equal to V by R. Similarly, we want to calculate this R. R is equal to V by I. All these three equations are important for the numericals. Okay. And yesterday we tabulate some readings. Do you remember that? Number of cells. Number of cells. Then what is our second column? The value of current. It is expressed in ampere. Third column? Voltage. And it is expressed in volt. And one more column is there. What is that? V divided by I. V by I. Alright. So in the first case we are introducing one cell. In that case, what about the reading of potential difference in voltmeter? If one cell is added into it, what about the reading of potentiometer? It is 2 volt. What about the reading of current then? 4. 4. If we are introducing only one cell, the voltage produced or measured by the voltmeter is 2 and the corresponding current in ammeter is given by 4. If we are introducing 2 cells, then the voltage becomes 4. And what about the ampere or ammeter reading? 8. If you are introducing 3 cells, voltage in voltmeter, the potential difference in voltmeter is 6. Here it is 12. If you are introducing 4 cells, then the voltage is or potential difference is 8 and we get the ammeter reading as 16. Okay. So now based on this, we can draw a graph. So we are going to draw a graph for Ohm's law. All of you write the draw the graph in your notebook itself, no problem. Okay, so here we are going to draw the graph. So what is the basic steps to draw the graph? Mark the axis, x-axis and y-axis. And what is this axis represent? Is it is x or y? The horizontal axis? It is x, very good. And what about this vertical axis?
X.
Vertical, it is y. And here we have an origin, right? Now, in order to draw this graph for Ohm's law, we take current along the x-axis. Current I along the x-axis. Current is measured in terms of ampere. It is taken along x-axis. And the voltage or the potential difference V is taken along y-axis. Now what is the value of current? Value of current is 4, 8, 12, 16. Okay. So we can take it as 2, 4, 6, 8, the even multiples. So mark the readings here. Here we can take it as 2, 4, 6, 8, 10, 12, 14. What about the reading of voltage? Voltage is also 2, 4, 6, 8. So mark the voltage here. The voltage is taken along the y-axis. Here we have 2, 4, 6, 8. Okay. Now we can mark all the points here.
We can't see graph.
Yes.
I can't see graph.
You can see the graph. No one can see the graph.
Can't. And now it came. Now,
Is it is not clear to you?
now it came.
Okay, all right. So here the voltage is at, sorry, not voltage, the current. We want to mark the voltage corresponding to the value of current. If the current is at 4 ampere, what is the value of voltage? Current is at 4, the voltage is at 2. Then what is the next value? Current is at 6. Next value is current is at 8. Current is 8 ampere. What is the corresponding potential difference? 4. All right. Then next one. If the current is at 12 ampere, what is the corresponding potential difference?
8.
12. If it is corresponding to 12, it is 6. Then I think it's enough, right? Anything more? I think one more is there, 16. If the current is at 16, what about the value of the potential difference? 8. Now we can join all these points. Yes, how it is looks like? It is a straight line. Okay. So the graph of Ohm's law is always a straight line. The IV graph or the VI graph. The VI graph for Ohm's law is always a straight line. Why? Why the VI graph is always a straight line?
Because the current is proportional to voltage.
Very good, because here the current is directly proportional to voltage or vice versa. The voltage is directly proportional to current. That is, whenever the voltage through a current carrying conductor or the voltage through an electric circuit is increases, the current is also increases. So from this we can conclude that the VI graph of Ohm's law is always a straight line. The VI graph of Ohm's law is always a straight line. The VI graph is a straight line. VI graph is a straight line for Ohm's law.
Thank you, for the graph.
Okay. So this is the graphical representation of the Ohm's law. In order to draw the graph, we take the current along the x-axis and voltage along the y-axis. Then we get a straight line graph, because here the voltage or the potential difference across the ends of a conductor in an electric circuit is directly proportional to the current flowing through the circuit. So whenever the voltage increases, the current that is flowing through the conductor is automatically increases. VI graph. And it is a straight line. It is a straight line. It's a straight line graph. The Ohm's law graph is always straight line, because whenever the voltage increases, current is also increases, because the relation between the potential difference and current is directly proportional. Is it clear?
Yes, ma'am.
Now here we have one more column is left. What's that? We want to calculate the ratio between the potential difference and that of the current. What is V by I? That is 2 divided by 4. The ratio between 2 divided by 4. 1 by 2. What is 1 by 2? 1 by 2 is equal to?
0.5.
Yes, it is 0.5. Similarly, what about the V by I ratio of the second reading? 4 by 8.
1 by 2.
Again 1 by 2, that is equal to 0.5. So here we have 2 by 4, that is equal to 0.5. Here we have 4 by 8, that is equal to 0.5. Again the ratio between the voltage and that of the current for third reading, 6 by 12. It is also 1 by 2 or 0.5. About the last reading, 8 by 16. It is equal to 1 by 2, that is 0.5. So what do you observe in this ratio between voltage and that of the current?
All are constant.
All are constant. So the V by I ratio of our Ohm's law is always a constant. The V by ratio is always a constant according to Ohm's law. And what is this V by I represents? V by I represents?
Resistance.
Very good. It is the resistance. No. The voltage divided by current. I represents the resistance R. So from this reading and from this activity, we prove that the V by I is equal to a constant. And that constant is known as resistance. It is the proportionality constant that introduced by our Ohm's law. And resistance is the oppositions to the flow of current, and its unit is ohm. And the resistance is always a constant for a particular material. Here we are consider a nichrome wire as our conductor. So the resistance value of the nichrome wire is 0.5 in this case. Is it clear?
Yes, ma'am.
Okay. So you must keep in mind the value of resistance is always a constant for a particular material. The value of resistance is a constant. Here we find the ratio of voltage and that of the current. The ratio of voltage and current is given by the resistance, because according to Ohm's law, we know that V is equal to IR, or I is equal to V by R, or R is equal to V by I. That is what is we are calculating here in this third table, in the third column. So we get it as a constant value. So the resistance of a particular material is a constant. I hope it is clear, right?
Yes, ma'am.
So from this activity, it's very clear that the voltage current graph is always a straight line. Then the next question, the next big question, what do you mean by resistance? Resistance is a property of conductor due to which it resists the flow of electric current through it. So resistance is nothing, it is the property that opposes the flow of current through a circuit. It is represented by a symbol. And what is this symbol represent? What is this symbol? It is a Greek symbol. Very good. It is ohms. It is the SI unit of the resistance. It is represented by a Greek symbol ohm. And this is the conventional symbol, that is we are used for resistance inside the electric circuit. We are already discussed yesterday. This is the conventional symbol for resistance. Conventional symbol for resistance.
Yes, for resistor.
Yes, resistor. Resistor. The device that is used for this resistance property is known as resistor. Okay. Resistance is the property that opposes the flow of current, and we are using a device in order to oppose the flow of current through a circuit. That device is known as resistor, and it is conventionally represented by this symbol. Resistance is the property, and this property can be accomplished with the help of a device. That device is known as resistor. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. Then can you define what you mean by 1 ohm? Here we know that the resistance R is equal to, the resistance R is equal to V by I. And what is the SI unit of resistance? Ohm. Ohm is equal to volt divided by ampere. Then what is 1 ohm? What is 1 ohm?
1 volt by 1 ampere.
Yes, it is the 1 volt of potential difference present in a circuit whenever 1 ampere current is flowing through it. Okay. Or whenever the 1 potential difference is present in a circuit, it will generate 1 ampere current. That is what is known as 1 ohm. So if you have a question like define 1 ohm, you must write this equation. 1 ohm is equal to 1 volt divided by 1 ampere. This is a sure question you can expect in the short answer session. Define 1 ohm, define 1 ampere, define 1 volt. All these are you can expect for your short answer session. So 1 ohm means the 1 volt potential difference present in a circuit, and that generate a 1 ampere current. That is what is known as 1 ohm.
Yes, ma'am.
Okay. Now, in certain cases, we need to increase or decrease the value of current while doing the experiments with the help of electric circuit. In certain cases, sometimes we need to increase and decrease the value of a current without affecting the value of voltage. Okay. We know that whenever the current increases, the voltage is also increases. Okay. Or whenever the voltage is decreases, current is also decreases. So, without affecting this voltage value, we can change the value of the current with the help of a device. That device is known as variable resistance. Sometimes while doing the experiment, we need to increase or decrease the value of current. And the only way now we are knowing that according to Ohm's law, whenever the voltage increases, current also increases. Whenever the voltage decreases, current is also decreases. But without affecting the voltage, we need to increase and decrease the value of current, or we need to regulate the amount of current that is flowing through a circuit. For that, we need another device. That device is known as variable resistance. Okay. And in electric circuit, a device known as rheostat is acting as a variable resistance. So let us see about the rheostat. Yesterday we were discussed the symbol, the conventional symbol of rheostat. This is the rheostat. You can find this device in your physics lab, rheostat. What do you mean by rheostat? Rheostat is a adjustable resistor, or in simpler term we can say it is a variable resistance. Rheostat is a variable resistance. Instead of using the term adjustable resistor, you can use it is a variable resistance. And what is the use of rheostat? It is used to adjust or vary the current. Vary the current by varying the value of resistance. It is not affecting the voltage. Without affecting the voltage, the rheostat is a device that is used to vary the value of resistance, thereby regulate the amount of current that is flowing through the circuit. Yes.
Stabilizer.
Which one, Ashik?
Stabilizer.
No. It is not stabilizer. It's another device. Stabilizer, we are actually used to regulate the current and also the potential difference. Here we are used to regulate the current flow of current through a circuit without affecting the voltage.
Yes, ma'am.
You don't need to copy down this sentence about the potentiometer. This is for higher studies, for +2 and all. This is not needed, only up to here. Yes. But rheostat is also known as a variable resistance. It is used to adjust the value of resistance or adjust the value of current by varying the value of resistors without affecting the voltage. This is the conventional symbol to represent the rheostat in a circuit. So if you find this symbol in your electric circuit, you must identify this is nothing, it is our rheostat. Don't confuse this symbol with that of the resistance. Resistance or resistor is represented by this symbol. Here an arrow mark is here to represent this rheostat. This is the conventional symbol for rheostat.
Yes, ma'am.
Okay, so that's all about our Ohm's law. This is a very important topic from this lesson. You must study the statement, equation and all the terms associated with it. That is resistance. Resistance is an important term and it is a proportionality constant that was introduced by our George Simon Ohm, and its SI unit is ohm. It is represented by a Greek symbol. And in addition with that, here we are introducing another device, that is rheostat. Rheostat is also known as variable resistance. It is used to regulate the flow of current through a circuit without affecting the value of voltage. Okay, so that's all for today. Can I change the slide?
Yes, ma'am.
Okay. So once again we can recall all the points that we were discussed today, and after that we can wind up this session. Then Arjun, state Ohm's law.
Ohm's law means at a constant temperature, potential difference.
Where this potential difference is present?
Conductor.
Across the ends of a conductor in?
Conductor in an electric circuit is directly proportional to the current flowing through.
It is directly proportional to the current flowing through the circuit. Okay, very good. Then next one to Afsana, what is the mathematical equation for Ohm's law? Afsana? The same question to Anne-Marie.
V equal to IR.
V equal to IR. Good. Then Johan, what is this R represent in this equation?
Resistance.
Resistance. Good. Then Rifa, can you define resistance? What do you mean by resistance?
Ma'am, R is equal to VI.
R is equal to VI, is it right? No. R is equal to V by I. R is equal to V by I. And what is the definition for resistance, Rifa? Definition. How we can define resistance?
Ma'am, it is the voltage present in the...
What is resistance? Fia? What do you mean by resistance?
Resistance is a property of conductor due to which it resists the flow of current.
Yes, resistance is a property that opposes the flow of current through a conductor. Then Aman, what is the SI unit of resistance? What is SI unit of resistance? Aman? Same question to Hadidi.
Ma'am, ohm.
Ohm. Ohm is the SI unit of resistance. Okay. And what do you mean by rheostat? Rizwan. What do you mean by rheostat?
Yes, ma'am.
What do you mean by rheostat? Rheostat is a variable resistance. Okay. The rheostat is a variable resistance that is used to regulate the flow of current through a circuit without affecting the value of voltage. Okay. Children, see you on the next class all. Bye. Thank you and have a nice day.
Thank you, ma'am.